Poštovane kolege, koleginice, upravo možemo da počnemo sa našim predavanjima po pozivu naših eminentnih gostiju i ja bih u tom smislu pozvao kolegu doktora Predraga Hrnjaka da prezentira svoj rad sa University of Illinois, da prezentira svoj rad pod nazivom Promene i tendencije u industrijskom hlađenju amonijakom. Izvolite, kolega.
Hvala puno. Hvala vam što ste ovde. Meni je uvek izuzetno drago da dođem. Actually, I should also switch to English. And today, at this moment, I want to have a relatively presentation at a relatively light note. If you want to hear something very interesting and very much in details, please come tomorrow. I have two quite nice talks. You'll love it if you are in area of refrigerant flows, in oil flows, in heat transfer. But today, I wanted to tell you something about the trends, which is easier, lighter for this beginning of the meeting. And I want to talk about trends in ammonia industrial refrigeration the way I see them. And I'd like to give you the update about the situation in industrial refrigeration, direction that the industry is taking to move forward towards lower charges, safer, simpler, and more cost-effective solutions. What is industrial refrigeration? Typically, it is applied for cold stores, process industry, big cooling stuff sometimes, sport complexes, typically custom design and built, almost always on site. Steel is a major material. High capacities, large components, huge refrigerant charges. Mostly uses ammonia because it is very inexpensive, efficient, good fluid. Proven over centuries now, we can say. Unfortunately, it typically requires professional personnel to run these systems. And let me illustrate that in a few simple slides. Everything is big in industrial refrigeration. Compressors are big, many of them. Accompanying vessels with a lot of charge. We are talking about tons and tons and tens of tons of ammonia in these systems when they are large. Typically, the size of the vessel could be translated into the charge. And that's sometimes not very good. Well, I'll tell you in a few slides just why I don't think it is good. There's a lot of equipment everywhere, on the roof, on the floor, left and right. With the numerous evaporators, disagree. And there is a very strong pressure for sound environmental solutions. Actually, this is very good for ammonia because ammonia is relatively, not absolutely inexpensive fluid. Now, equipment may or may not be, but definitely ammonia has a good position. It is seen as a zero GWP or very low GWP and very efficient fluid. The statements in bold that I put here at the end, are we waiting for big earthquakes in California, which it is not a question whether they will happen. It is just a question when it will happen. Something like what happened in Japan, in Fukushima, to realize that not only nukes could be a problem, but also big industrial refrigeration systems, especially in LA area, in Los Angeles area, where these big industrial refrigeration systems are now almost in downtown, in the center of the city, and if there would be a big earthquake, we could be facing a potentially dangerous situation with tons and tons of ammonia in a highly populated area. So, what can we do? And what is happening right now? And I think this is that trend that I wanted to tell you something about and shed some light on it. And this is decentralization. And what we see today is that people are thinking and building multiple units of lower capacities with the smaller sizes. That means reduced charges, and even in a case of a leak, that is really minuscule amount of ammonia. It is safer, and, and it is possibly less expensive. And I think that's the key. What we see, I think industrial refrigeration is probably the last segment of our industry where contractors are dominating the field, not industrial companies. And many larger companies have realized the opportunity to take a bigger part of the cake and make mass-produced systems that would reduce the cost and give them a little bit more possibility to make a profit. I think that is one of the reasons, besides safety, why we are seeing these changes that I'm trying to tell you something about. And these are these new markets. Basically, this is open area for those who have a good product to come and fight not against their competitors, but somebody who is not very well organized. There are various options to fit different applications in the directions that I'm talking about. First step, and that's what some people are doing, is to shrink the big machine room into the small container-like structure. And this is what you see over here. Everything what would be in the normal machine room is reduced, it is enclosed, and will be put on the roof or maybe on the side next to the cold store. The other option is what we see. I have here borrowed from MICOM's their system, prefabricated system, which is a chiller for carbon dioxide. So you have ammonia chiller that cools carbon dioxide, and then carbon dioxide is pumped throughout the facility, and that is the way to reduce the charge and reduce the time of building, erecting the system in the field. The other, and I will spend a little bit more time on this, the other option is to basically think about industrial refrigeration same as you would think about air conditioning systems, where you have rooftop units put on the roof, and with no or just a little bit of ductwork, you serve the purpose of that unit. That means to provide the cooling to air or maybe something else. So this is what I'm presenting here, and these are typically in a sizes of something between 100 to 300 kilowatt capacity. And we see them today in various options, with evaporative cool condenser, with water-cooled condenser in the cooling tower, and the air-cooled condensers. And I have had the pleasure to be in this distribution center in Long Beach when they were putting on the roof these something like 27, 28 of these units in the big distribution center in Long Beach, basically in LA. And you see many of these kind of container-like units, like air conditioners, put on some Walmart or some other big supermarket. Here we have a cold store with cooling systems, rooftop cooling units. And these boxes typically, almost always, have two parts, condensing and evaporator part inside. And in this particular case, I'll tell you something more about this. Is a kind of miniature cooling tower. And that cooling tower, the purpose of this cooling tower is really to reduce condensing temperature and to reduce the discharge temperature of the compressor. So that's why. I would maybe question whether that's the most, the simplest or the cheapest option, but definitely one of the options. And you see here then this miniature cooling tower and nickel brazed stainless steel condenser for ammonia. So this here happened to be something around 100 kilowatt capacity. It's relatively small, very small screw compressor. And this screw compressor is open and it is presented here. Even I will show you in some other slides that there are more and more hermetic compressors for ammonia. That is also maybe new to some people. So this is that compact screw compressor with controls, with a pump for cooling water, and variable speed pumps and also variable speed compressors. Evaporators, of course, stainless steel. I would maybe think about using something like aluminum or something cheaper, but they don't want to take a risk, especially in the first approaches. But what is very interesting and what I wanted to show to you is this unit here, which basically is a controller of an exit condition from the evaporator, which provides wet exit and much better heat transfer in the evaporator. That is a relatively new approach with the capacitive probe. This is how it looks like from inside. And I was there when they were opening. These here are opening, before opening and after opening of these holes where air will be turned up and pushed down. It takes a little bit less even than 20 minutes with a sawzall to come there and cut the hole. And while I was there, trucks and trucks were coming with the new units that were pre-assembled, and then the crane was putting them, same like you would do with the rooftop units, as I said, in air conditioning systems. Very similar to that. These chambers and corridors are cooled from above. This here is that opening, and you see how tall is and another opening with, this is without unit mounted and this is with unit mounted, and that is how it looks like. In addition to that type of approach, some people, and I have here cited Italian company Zudek, these guys are not afraid to make a rooftop unit with microchannel condensers for ammonia made out of aluminum tubes. And when I was doing that 20 years ago, people in industrial refrigeration were making fun of me, saying it will never happen that somebody will make a microchannel condenser for industrial plant. They say, have you seen any condenser that has a smaller tube than 3/4 of an inch? And I said, yes, I had. But anyway, what else is happening new? Hermetic ammonia compressors are helping in my system solutions, in my mind, solutions for the smaller ammonia hermetic systems, because with these hermetic compressors, either scroll as presented here or reciprocating with hermetic compressor, it is possible to make a chiller identical as R22 chiller that behaves same as R22 chiller, it acts, and it just has ammonia, which is definitely extremely low, if not among the lowest GWP refrigerants, and probably the highest efficiency. And of course, this here is the first, to my knowledge, the first commercially available system, and we have made this condenser For the MICOM, this is a prototype of their hermetic scroll compressor. And that is this chiller, ammonia chiller, is installed in Japan as a heat pump and a chiller in numerous places. We have started this over 15 years ago with the first chiller. This is in my lab with the open Bitzer compressor, stainless steel, Alfa Laval, brazed condenser, evaporator, and condenser is microchannel over here that we have been using later at CTS for various needs. And then today, that means a year ago, we have built our first, newest air-cooled chiller with microchannel condenser and here open compressor still. Oops. And as a conclusion, I wanted to say that I believe that ammonia industrial refrigeration demonstrates vitality and evolution. If there is a need, because people typically think about ammonia industrial refrigeration segment as very, very conservative and traditional, unlike air conditioning that had a better ear to the needs of society, to changes. Now we see that even industrial refrigeration people are starting to evolve. Decentralized system, in my mind, with a very low charges in a main direction that we see today. There are several big companies that are posed to take a big part of the market, and I believe in next maybe 5 to 10 years we will see several of them more. Variety of solutions address diversified requirements, so maybe you want to cool either secondary fluid or air or CO2 chiller or something like that. And I believe that the extremely low charges are the next step to go. How low is low? It is presented here. 18 grams per kilowatt was the charge of our first ammonia chiller that had 15 kilowatt capacity at normal conditions. Give me any fluid, give me any unit that has anything similar to 18 grams per kilowatt charge. I challenge you. Today we have per kilowatt 150 grams of propane or isobutane allowed, or that is what typically people see. We have made it for less than 50. But ammonia is phenomenally good fluid for charge reduction for various reasons, primarily for thermophysical properties of that fluid. So with this, I would end up my presentation. Be open to, I know that we don't have time now for discussion. I'll be here to talk with you if you have any interest. And tomorrow morning I have two great, lovely, interesting presentations. Come and see that and we can talk even more. Thank you very much.
Zahvaljujem kolegi Hrnjaku na inspirativnom prezentaciji i uvodu u ono što će se dešavati na